Learning target of this video is I can write an absolute value function given a graph. So we're going to be given several graphs here and we're going to be asked to write the equations that represent the absolute value function graphed on the coordinate plane. So when we do this, when I'm looking at this first graph here, what I want to do is I want to label the vertex point here at the bottom. And then I want to follow the line and see where it hits where the grid lines meet. And I want to put a point there on both sides. Okay, so I want to kind of label or darken in the 3 points. Okay, now when I do this, I'm going to write y equals, and I'm going to put an absolute value bar. And I'm going to try and fill in the different transformations that I see. So I look to see how has this vertex point been shifted from the origin. Well, I notice it's been shifted over 1, 2, 3, 4, right? We've been moved right 4 and down 1, 2. So I have to think about what in the equation will move me right 4. Well, to move to positive 4, it's actually the opposite. It's negative 4, right? Negative 4 moves me right 4. And then if it's been shifted down 2, that means I have a negative 2 on the end. Okay, so this equation, y equals absolute value of x minus 4 minus 2, shifts me right 4 down 2. And then the reason why I needed to darken in these 2 points is because when I go over 1 unit, I need to see how much did it go up. Well, it goes up 1 here, so I have a vertical stretch of 1. So I can write a 1 there as well. So my equation is y equals 1 times the absolute value of x minus 4 minus 2. This would be the equation for the first graph. All right, looking at the second graph then, so same thing. I'm going to darken the top point, and then when I follow the lines, I see where the grid lines meet, and I'm going to darken in those 2 points. And then I start with the shift. So I'm going to write y equals absolute value of x. I'm going to leave some spaces because I might have to fill some information in. So when I look at this, it's going to go left 1 and then down 1, 2, 3. So negative 3 on the end moves me down 3. And then I just have to think about what moves me left 1. Well, left 1 is negative 1, so it's the opposite. It's going to be positive 1. Okay, so the shifts give me this first point. And then once again, like I said, I look over and I see, okay, when I go over 1 unit, what happens? Well, it goes down 1 unit. So I'd have to have a negative 1 out front or just negative in front to flip my graph over. So this would be the equation for the second graph there. All right, then looking at the last 2 examples here. So this one, I noticed that the first point here at the bottom is at negative 5. And then when I track that, I see it hits the grid here and it hits the grid there. Well, notice that it's not horizontally shifted, right? The origin's straight over top of it, so it's only been shifted down 5. So I have the absolute value of x minus 5. Okay, I'm only shifted down 5. But when I look over 1 unit, I notice that it goes up 1, 2, 3. So I have a vertical stretch of 3. So I should get y equals 3 times the absolute value of x minus 5 as the equation. And then lastly here, the last one, same thing, label those 3 points. So darken in this one, track the line, see where the grid lines meet up. We want to darken in those 2 points. So when I write this equation, I've got y equals, I've been shifted left to negative 4, so that's going to be x plus 4, that takes me left 4. And I've gone up 1, 2, 3, so I'm going to have a plus 3 on the end. Last thing I look at is when I've been shifted over 1 unit, I notice it goes down 1, 2, so I'm going to have a negative 2 in the front. Okay, so this equation's left 4, up 3, stretch of 2, and it's been reflected going down.